interesting creature. We have one more little topic to talk about today, and it's going to be a little bit of a paleo peek. So I'm always going on and on about New Zealand, right? I love the formations and stuff in New Zealand. We are going to be exploring the deep secrets in New Zealand. So come along with me for Paleo Peak, where we discover the deep secrets of New Zealand and discovering New Zealand's tropical past. There was a sense of expectation as we drove down the broom-lined track towards the Manuherikia River. It was December 2001, and we hoped that exposed layers of sediment in the Bannockburn Formation would reveal a bone or two. Bones that would help us understand what New Zealand may have been like 16 million years ago. We could not have known what treasure troves lay in wait. Manuherikia the Manuherikia River flows down a valley of the same name in central Otago, bubbling through rifles and pools and other millions of years of history. This was once an enormous lake stretching from Nessaby to Bannockburn and ran further to the Wataki Valley, an area 10 times that of Lake Taupo. It swarmed with life, which thrived there and then perished in the silty lake bed and remained there to this day. A quiet record of creatures unique to New Zealand from a time well before humans. Alan Tennyson of Te Papa Museum, Craig Jones of GNS Science, and Trevor Worthy of the University of New South Wales began surveying exposed sections of gravel, mudstone, and shale along the riverbanks. Within minutes, someone had discovered a bone protruding from the bed of a Miocene sandstone. And in the next hour or two, the 100 meters exposure revealed several more. They were small, brittle, and bleached where they protruded from the sediment. Some were broken by the turbulent course of the past 16 million years. Others were perfectly preserved, the finest details cushioned by the mud as if they were wrapped in tissue paper. These were discoveries beyond the paleontologist's wildest expectations. The bones of creatures long extinct and unknown to science, simply waiting to be dug up. The next day, they headed to another site, affectionately known by paleontologists as Croc Site, because it was from here that a crocodilian bone had been described in 1997, the first and until then the only example found in New Zealand. And these are Nicosuchians, I believe. So they're a specific group of land crocodiles that had zygodontic teeth, which is like serrated, not for grabbing like an aquatic animal, for grabbing and pulling into the water like modern crocodiles generally do. But these guys, they had sharp teeth like terrestrial carnivores, like Komodo dragons, for instance, or what else had dinosaurs had teeth like that too, terrestrial dinosaurs. Where was I at? Okay, the Croc Site. We quarried lumps of the sandstone and put them in our sieves to break down in the flow of the river. Over the course of an hour, the silt washed away, leaving pebbles and a macabre assortment of bone fragments. First bird bones, and then a great flurry of excitement, a tooth, unmistakably crocodilian. That New Zealand once hosted a crocodile of sorts was interesting enough, but here we were all gathered around the sieve, staring at a 16 to 19 million old fragment of history, complete with root and crown, as though it had fallen out of his own mouth. There's a picture of the reconstruction. Little did we know that this find would set us on a journey of discovery that would continue for almost a decade, with expeditions every year. Through the heat and drought and the icy cold of sleet and snow, the Otago Hills offered up a hugely significant trove of fossils, revealing with each dig another small piece of New Zealand's prehistoric past. Paul Schofield of Canterbury Museum and colleagues Susan Hand and Mike Archer from the University of New South Wales have joined the search in recent years, excavating several sites around the St. Bathan's township. Initially, the work was funded by the Foundation for Research, Science and Technology, but in recognition of the international significance of the find, grants from the past 3 years have come from the Australian Research Council. The discovery is unique in part because of its age. Most of the bones are thought to be between 16 and 19 million years old in the Miocene period, long after the extinction of the dinosaur. So, this is super interesting. This is going to be kind of a long read, so I hope you guys are in for the long haul. I need to take a quick drink. All right. Think of time as if it were a ruler. In a year was the equivalent of just 1 millimeter. Then 1,000 years would represent a meter. Join me now on a journey, the first half step of which represents the arrival of humans to New Zealand. The 2-meter mark is where the Roman Empire was at its height. The 3-meter mark is where the Polynesians began to push into the Pacific. The 100-meter mark down the track, early humans walked out of Africa into Asia and Europe. Some 4 kilometers on, we reach a point that humans first evolved, and somewhere beyond the 16-kilometer mark, as far as the upper hut of the Wellington, we reach our destination, the Miocene period. The St. Bathan's landscape looks very different. A vast lake stretched out to the west and south in front of us, time travelers, and from the north to the west of a range of high, rounded hills framed the horizon. Broad, braided river beds fanned out from these hills, carpeted in white quartz pebbles, and not far off, one of these enters the lake before us. It is late in the summer, and the land is in the grips of drought. The waters have receded. The broad, flat mud flats extend far from the lake's edge. An abandoned channel from the river's delta contains a remnant pool teeming with life. Herons stalk the shallows, kite-like raptors sitting in overhanging palms, and further along, a group of gulls squabble over fish. Seeking the source of this excitement, the time traveler may soon notice beds of dead freshwater mussels, schools of fish swimming back and forth, and galaxid struggling and gulping air in the deoxygenated water. One fish, somewhat bigger than the rest, swims erratically, then finally goes belly up. The kites swoop down from their perch and haul it from the water. Here's a reconstruction of the lake bed and all the myriad of life they found. Very avian life. Numerous small waders feed on the exposed mud flats, and out in the water there's a group of large paleolids, the ancient short-legged cousin of the flamingo, like short-legged flamingos. Isn't that wild? Walking along the shore, we come along. And the thing about flamingos that people don't think about too is that flamingos are freaking extremophiles. They live in extreme climates. I will cover that in more detail at some point in the future. So stick around for that as well if you like that kind of topic. Where was I? Walking along the shores, we come to a small embayment where the water is deeper and extends up to a shallow bank. Here, reeds and grasses grow close to the edge, and small flightless rails sneak out about close to the cover. Great flocks of ducks clutter the water. More waterfowl graze on grass on the banks. A slightly longer legged version of the paradise shelduck and a goose. Further back, a stout meter-high bird with a huge recurved bill. An adze bill is ripping rotten wood and bark off fallen trees, searching for large insects or lizards. Extending back from the lake's edge is an open woodland with casuarinas, eucalyptus, palms, and cycads. The grass is dry and sparse. A large nest hangs from an isolated eucalyptus, and soon its owner appears, an eagle with a 2-meter wingspan, flying in carrying a duck to feed two hungry eaglets. Away across the flat and along the riverside, the trees are taller and closer together, and podocarps tower upward. Noisy flocks of parrots feed in the canopy, and nearby large pigeons gorge themselves on fruit. Numerous small songbirds flit about the trees, and the smallest of all, a thimble-sized ball of feathers with no tail, emits a high-pitched squeak. Soon another joins it, and together they rapidly dance over the tree trunk, investigating small cracks in the bark, then disappearing from view. Farther along the raised banks of the river, a clearing allows the sun to warm the forest floor. Above a well-beaten trail to the riverside, a meter-long crocodilian slumbers in the sun. And off in the undergrowth, a rustle betrays a furry critter the size of a small rat feeding on invertebrates in the leaf litter. It is now 2010. The team excavates and sorts tons of sediment and identifies thousands of bones. We have revealed much about the Paleo Lake Manuharakia and its environs. Geologists have mapped its extent, a staggering 56,000 kilometers, 5,600 kilometers, extending from central. It sounds so much less impressive when I say 5,600. Extending from central Ontario to Nevis Valley and Bannock Burr in the southwest and west, to Naseby in the east, and from the north in Wataki Valley. I'm sorry to any of the indigenous names that I'm butchering here. I do apologize. I don't know the proper Maori pronunciation, so please forgive me. To some way south of Ranfurly. It existed on Zealandia long before it took shape in modern-day New Zealand. This lake was preceded by a broad alluvian plain across which flowed a braided river. Later, the river became impounded with swamps, with diverse rainforest vegetation developed, forming what was to become deep beds of lignite. Then the lake flooded the forest and persisted for millennia while the climate became seasonally dry. The layers of rocks record oscillating water levels deep water supported ostracod and fish, as shown by their fossils in layers of clay. Then came a period of drying out with cracks forming in the exposed mud. Next, a flood swept through, laying a veneer of sand, small pebbles over the other deposits. It carried with it the bones of dead fish and shells from the dried channels, bones of dead birds and other animals, even shells of tiny mollusks from the nearby shrublands. Some of these were swept back and forth in the shallow littoral zone of the lake, and some accumulated a patina of calcite laid down by microscopic algae which lived on the bones. Soon deep water returned, and in time it buried everything in sediment. This was a cycle repeated numerous times over millennia. In some places, the layer of rocks contained fossil accumulations as rich as any found in the world. Often they are densely spaced, as one large bird bone per 30 square centimeters, but it's the small bits that fascinate us. We wash the sediment, wash it again, and after it dries, it's sorted under a microscope, half a teaspoon at a time. In one quarry, we have excavated 110 square miles, putting the entire 10 to 15 centimeter thick target layers through this process, amounting to some 10 tons of concentrate. That's a lot of sifting these folks are doing. I gotta hand it to them. It has been long and laborious process, but never boring. Placing a teaspoon of processed sediment on a tray and peering at it through a microscope engenders a huge sense of excitement and anticipation. You are the very first person to look at these fossil bones, which are up to 20 million years old. Every teaspoon has the potential to reveal a new species or more parts of one that was already found. We had spent weeks searching through muck before it revealed itself, a beautiful, sparkling little transparent mammal tooth with all its cusp and roots. 20 minutes later, another appeared. Weeks elapsed, and doubts crept in that we were missing them. Then, after sprinkling a few grains of sediment into a petri dish, grains that looked no different from the last few million, there, as clear as a bell, was yet another beautiful tooth. But teeth are not the only gems. Perfectly preserved bird and lizard bones appear under our microscopes, and tiny, exquisite snails barely 3 millimeters across. Each gem is carefully picked up with leaf tweezers, sealed in a gelatin capsule like those vitamins are stored in, and labeled. To become lazy, to miss a single tiny tooth, may be the difference between finding a new species or remaining forever in the dark. The haul so far has been impressive. It contains large hyoid clams, freshwater mussels, and small freshwater gastropods that we expected. But the small 2 to 4 millimeter wide land snails still retain color within their shells. Were a surprise. Fragments of yabby buttons, the calcium deposits from shell changing, and even a couple of examples of stomach grinding plates attest to the presence of freshwater crayfish, much like those found in the waters of Otago today. But we are vertebrate paleontologists, so bones were what we were wanting. And bones by the millions were what we got. Fish account for 99.99%, upteen thousands of them, and many more thousands of otoliths, calcium carbonate structures from within their heads. We now know that these fish derived from several kinds of bullies similar to those in the New Zealand streams today, smelt in several kinds of galaxids. Famous as adults of the New Zealand delicacy whitebait, surprisingly, not an eel remnant has been found. But for every 100 or so fish bones, we got a fragment of something else. And 1 in 100 of those is a bit we can identify. After 9 years sorting, we have identified many species. We have 3 kinds of frogs. Reptiles are represented by lizards, a couple of species of skinks, and geckos, much like those of today, and tuatara-like animals as well. But we can also be sure that long ago, New Zealand was not a safe place it is today. It harbored crocodilian creatures up to 3 meters long, now known from many bones and teeth. But birds dominated this fauna. There are more than 35 kinds in the fossil record, but as of yet, only about a dozen have been named. We have moa, or at least moa ancestors that were large and flightless, represented by eggshells and a few scraps of bones. The eggshells hint at a bird every bit as big as the little bush moa, Animalecteryx, that was present in New Zealand immediately before the arrival of the first humans. 8 species in 6 genera of waterfowl, including ducks, shell ducks, and geese, combined to make St. Bathan's the richest known site of Miocene waterfowl fauna in the world. The flamingo-like paleolids are represented by a single species, unlike those found in Australia at a similar time. There is a single species of heron of a new primitive lineage, the first and oldest for Australasia. Raptors are represented by acipterids, 2 kinds of eagles, and a kite-like raptor, though no falcons or owls have yet been revealed. A large guiform, a crane-like bird, probably the ancestor of Aptornis, the weird adbill known from the Holocene, was represented by vertebrae, a part femur, and a phalanx. In the same order, but of a diminutive size, are at least 2 species of small rail, one of which was flightless and barely larger than a sparrow. Even seabirds have turned up. There are bones of diving petrels of a form very similar to those living now, and doubtless they would have fed at sea during the day and nested on inland hills at night as they do now. Other water birds include gulls and waders, somewhat like the dotterels and sandpipers that frequent lake margins today. Of more terrestrial birds, at least 2 kinds of pigeons, 3 parrots, an owlet nightjar, and a swiftlet, and 4 or more passerines ranging from magpie-like birds to diminutive wrens existed about the lake. Many of these birds have yet to be described in detail. Most surprising of all, the mammal bits. The terrestrial mammals, dubbed the waddling mouse, was a find of huge international significance. About the size of a small rat, it is neither a placental nor marsupial mammal. And so, like Leoptomatid frogs and tuataras, represents the last survivor of a lineage that died out elsewhere many millions of years ago. So just to pause from reading here and express how significant this is, to find a group of organisms within the recent the Miocene, that's not too long ago, it's 20 million years ago, that is not a placental mammal, that's not a monotreme, and not a marsupial, So marsupials and placental mammals are the therians. I believe this sucker is supposed to be therian too, but we'll get there. Just hang in there. We're going to talk more about this. We have several bits of this intriguing critter now, but not the molars that mammalian paleontologists crave. We do, however, have more than a dozen teeth and bones of several kinds of bats. One is the mystacinid, a short-tailed bat ancestor, revealing the long heritage of New Zealand's special bats. Another is of an entirely new family, unlike any in Australia. On each field trip, we collect new, exciting mammals. 2009 saw one of the largest, the first bones of the Aptornis ancestor, and one of the smallest, representing an intriguing new family of birds. New Zealand has long been considered the land of birds. Now we know for the first time that this was the case in the Miocene period too. But back then there were quite a few differences. We had a terrestrial mammal, whereas none survive today, and a crocodilian, not just a nipper either. Other clues as to what has happened are seen among the species that we have lost. The ancestral flamingo, the swiftlets, are strictly tropical today, and the plant community, the story is the same. Eucalyptus, casuarinas, cycads, and palms, and a multitude of laurels have all deserted New Zealand for warmer latitudes. From the time of the Paleo Lake Manuhirakia, the Earth cooled 8 degrees Celsius during a period called the Middle Miocene Transition, 14 to 13 million years ago. On top of this, the Pleistocene glaciation over the subsequent 10 million years brought another 5 degrees Celsius drop in temperature, rather too much for New Zealand's tropical heritage, which was all but eliminated. Nevertheless, many of the animals we had in the Miocene, the frog, tuatara, skink, gecko, and many of the birds, owlets, nightjars, shelducks, pigeons, and diving petrels, were allied to those surviving today. None of these species exist in Australia, and few even share the same genus, as an exception being the Paleolotus, which was globally distributed. Even the waterfowl, which are relatively well described and include at least 8 species, were all different from those then in Australia. Clearly the fauna 16 to 19 million years ago was already very much Zealandian, reflecting a long, unique heritage dating back to our physical connections with Gondwanaland. With Gondwana. We have lost many of our heritage taxa since, allowing a few Australian immigrants to arrive, and evolution has seen the replacement of many other species, such as waterfowl and rail and Mystocenid bats, but Zealandians we remain. Yeah. Those that survived the ever-descending temperatures, the retreat of the subtropical forest, and the raising of the mountainous landscape we know today, became masters of adaptation and now stand out among animals elsewhere on Earth by their appearance, habitat, and behavior. As much as New Zealand is unique for the fauna we have lost, it is also famous for what has remained. This is a nation of survivors which have been encouraged by circumstances to do things somewhat differently than elsewhere. The survivors of St. Bathans were adaptable and unspecialized, qualities which have lived on in the culture and psyche of New Zealand society that follows. There we go. That was the St. Bathans formation. A little bit of a breakdown. They had they didn't go into detail, but the bats they're talking about, my astacinids, They are more terrestrial. There's actually surviving descendants of them. They're called burrowing bats because they live in holes in the ground. They'll use old burrows of other animals and things as hideaways too. And they're very terrestrial. They actually have a flap that they fold their flight membrane underneath so that they can move around on the ground. And they're very skilled at terrestrial locomotion, which is not common in a lot of bats. So very cool. And again, about this mammal that was found there, the latest surviving member of this weird unknown group of organisms. It's fascinating. Early Moa ancestors. These are the articles that I had set up and primed for my debate with Matt Powell that never came to fruition. I wanted to debate evolution using New Zealand as my flagship, and it never came to fruition. Unfortunately, but that's how things go. That's about all I got for you. Thank you for joining me live from the Hive. Please don't forget to like the video down below. I got 28 thumbs up so far, so that's pretty good so far. But I think we can get a Copperhead Road, not Cottonhead Road. Yeah, that's the first song I learned to play on mandolin. Yeah. All right. Please remember to be kind. Take care. And we will see you next time.
Oh yeah.